G'day everyone, back here again. This is the fourth video I think for today. Now this is really something you want to get hold of and get hold of early. So if the other videos didn't make a lot of sense, you can build those skills over time. This one you've really got to understand from the start, and if you do, then like I always say, it's not about the numbers, it's about the understanding. So please watch this video a couple of times. I'll try and be as succinct and neat as I can here so that it comes across real well. So what we're now doing is we're doing the scalar product form of a vector equation. The scalar product form. Now, key things. Product means multiply. So somewhere in here I'm going to have to throw a multiply in. Scalar, you remember vector scalar, so we've got to somewhere have a number that doesn't have I's and J's and direction and stuff like that going on to it. Form, well that doesn't really matter, of a vector equation. So it's got to describe a vector. So breaking that down, scalar product form of a vector equation. Right, we know this guy here. That's a vector equation, okay? It's very similar to a linear equation. It gives us a start point, it gives us a gradient, and it gives us an x value or a t value or how many lots of that gradient direction part that we have. And that's okay. That's okay. Now maybe this could be point A here, and this could be the direction B part here, right? So we could have A, we could have B, and that's fine. But what happens if we don't have a start point, we don't have a direction? Perhaps we have these two vectors, A and R, they're the common ones that are used, but really you could use anything. Two vectors that both are on the line. That's what we're talking about here. We've got two vectors, both of which give me a point on the line. Okay? Now from that, can you reason that if I want to get the B part, this part here, then I would do this one minus this one. Because think, if this is 5, 5, and this is something like 2, 2, then 5, 5 minus 2, 2 gives me 3, 3, being that how do I get from here to there? Okay, so R minus A is going to get me this here. Okay, here's another way of thinking about it. Start here, minus A would move me back to the origin, plus R would move me to here. So where have I moved? This distance here. So however you want to see that, doesn't matter, but R minus A will give me this direction right there. Now, here's the next key step that we've got to be aware of. From your year 11 work, you would have done a little bit about the normal to the plane, or possibly not, normal to a line. Now the normal is just the vector that crosses exactly at 90 degrees. Okay? It doesn't really matter whether I put it this way or this way, because this one and this one are going to be the same. I just throw a negative in there. It doesn't really matter. It still describes the same. And in reality, if this was in three-dimensional space, this could be any way around that line. So it doesn't really matter, but the normal is at 90 degrees. Now, if the normal is at 90 degrees to the line, couldn't I dot this line, this one that I just found out, with this one being the normal? And if I did dot those two together, wouldn't they equal 0? Because product, well there we go, there's my dot product, I've got product in there. Scalar, that's coming in a minute. Right, let's expand this out. Okay, let's expand this out. If I multiply this out, I'll get Rn minus An equals 0. And you could leave it there. But generally what we do is we say R dot n equals A dot n. And then because we're mathematicians and we don't want to make things fancier than they have to be, we realise that this here, if A is some point that we already know, okay, then a point multiplied by the normal, dotted to the normal, will give me a scalar answer. Right? Think about that. Because I'd multiply the i's together and the j's together, and I'd get just a single number answer. Because I would get a single number answer, we generally write this one in this format here, right, where C is the dot product between a point and the normal. Now, that by itself doesn't really help you much. It's the scalar product form of a vector equation, and you need to recognize it. But the most common way that you'll see it, and I might use this example now to show you, the most common way to use it would be actually to put it in a format that I can see something with. So take this, perpendicular to this and through this. So a quick sketch, what does that mean? Well, perpendicular to that. So if 3i plus 4j, 3i plus 4j is here. That is that. The line that I'm talking about is perpendicular to that, because that would be the normal. So the line I'm talking about is this one here, where that's perpendicular to it. And through this point, because that by itself is just telling me a family of lines, because this one would work, oh, not quite, I'll try and do that a bit better. This one would work, and this one would work, and this one would work, and all of these would work just with that piece of information. But it's also got to go through 2i and 3j. So if we go with 2i being about there, and 3j being about there, then the line that I want is that one there. That green line is the one that I want. All these red lines are not the right one. I don't want those. They are all perpendicular to this, but only this green one is the one that I want. So the green one is the one that I want. So what am I going to do? Well, using this formula, r dot n equals c. Okay. Well, r dot n, I'm going to put in here, this is the normal. That's going to fit in there, and it's going to fit in there. Okay. So let's do this. That there, I'm going to put here equals, right. So I'm kind of come back to here, and I've put n in for both of these. I'm going to put this one in for A. So I'm going to put this one in here. And I'm going to leave R there. Now this is where the scalar part from my dot product. So my final equation is going to be R dot 3, 4 equals 6, 12. What's that? That's 18. So that now is my vector equation of the line in scalar product form. Now you might go, well, that doesn't tell me anything. Well, actually, to me, it tells me a lot, because it tells me the normal to the line that I'm working with. And if I wanted to test another point, let me say I find this point here, and I say, well, I'm not sure whether that's on the line or not. I would just need to figure out the I and j, put it in here, multiply these two, and if it comes up to 18, then it is on the line. If it doesn't come up to 18, it can't be on the line. And come back to here. If that point was not on the line, let's say the point was here, then the connection between these two, can you see the connection between these two, would not be normal to 90 degrees to this line here. Carry it on. That, not 90 degrees, so therefore it wouldn't equal 0, therefore it's not on the line. So bring it right back to here and say if that point wasn't on the line, it was off the line, then the line then so formed between here and here is not going to be normal, or it's not going to be 90 degrees to the normal. So this actually tells me quite a lot, and we can work with this quite a lot. Now here's the cracker part of this. Here is the cracker part. You want to convert this to a Cartesian form, kind of x's and y's. This is all you do. Instead of r there, just write xy. Because r is, it has an x component, it has a y component. So just write xy. That's all you need. And watch, the rest falls out. 3, 4 equals 18. Well, just like I multiplied these out because they were dotted, these are also dotted. So what do we get? 3x plus 4y equals 18. There's my Cartesian form of that particular question I was trying to find. So this green line is going to have a Cartesian form of that. It's going to have a scalar product form of that. And then if you wanted to, not from this information, but if you wanted to, you could write the vector equation of a line in more of a linear format. Back in this format here, the vector equation of a line in the simplest format. There's a lot in this. Please watch this video again. Get the idea of what we're doing. Understand where this comes from, because then the questions are quite easy. But if you don't understand this and this is all just numbers. It's just going to go haywire for you. Please ask me if you want more videos on this. I'll do a couple of examples in a little while. Well, there's one there, but if you want more, please ask me. Just down here somewhere is where it says to email me. Thanks, guys. See you later.